Good afternoon. I'm Jade and today I'll be sharing my AP research project on microplastic pollution in beach sand. This topic not only affects marine life, but also has serious implications for human health and our local ecosystems. So now let's dive into why this issue matters, especially here in St. Lucie County. So, how does plastic even end up in our oceans? Well, there are multiple pathways through which plastic enters our oceans and beaches. Littering, overflowing trash cans, and storm drains all allow plastic debris to wash into waterways. Wind and rain then carry this waste further into the ocean, and it travels across the entire world. Interestingly, this is not how 90% of plastics enter our ocean. The U.S. appears to contribute little to plastic pollution directly, but that's a little misleading. As the U.S., we export about 80% of our waste to countries like the Philippines and China and other third world countries. In the Philippines, about 20% of that waste is dumped directly into the oceans. Ocean currents then carry these microplastics globally, meaning the plastic waste we export and can end up directly back onto our own beaches. As you can see here by the current chart, the currents spread globally and the water gets washed all around the world to different beaches. So this leads me to my question. How does the level of human activity like tourism and coastal development and foot traffic affect the concentration of microplastics in the beach sand within St. Lucie County? This is going to test whether or not the currents evenly distribute the microplastics throughout all our beaches, or that just locally specific population levels within those selected beaches may increase or decrease the microplastic concentration. So why does this topic matter? Well, although research has been done on microplastics in ocean water, there's still very limited data on beach sand, especially how levels vary based on human activity. And given Florida's heavy tourism, it's important to examine whether foot traffic and urban development influence beach contamination. So before we go any further, let's go into some key terms that are needed in this presentation. So microplastics. These are plastic particles ranging from the size of 5 millimeters to 1 nanometer. Protected areas or state protected beaches. Beaches that are part of wildlife or convention programs, often with limited human access. These are often pay-to-enter beaches. Endocrine disrupting chemicals. Chemicals that interfere with hormone systems, often found embedded within microplastics. So plastics. Now let's go into the effect on humans. How do microplastics affect us? Well, microplastics have been detected within lung tissue. This may cause inflammation and respiratory issues and can contribute to long-term respiratory issues. And they've also been found in our bloodstream. Studies confirm that microplastics can and will enter into our bloodstream and can travel to various organs. They've also been found within our brains, and this can cause brain fog and other neurological disorders. They've also been found in our kidneys and liver, and this can interfere with the detoxification process and can lead to organ damage over time. They can also interfere with our reproductive system and can be linked to fertility issues. Studies show that we are ingesting up to 50,000 microplastic particles annually, and this is on the low end of estimates. So how do microplastics get into our body? Well, there's ingestion. So we can eat food that is contaminated with microplastics, or maybe animals have eaten microplastics, or drinking from single-use water bottles where plastics leach into that water and we drink it. And inhalation, so the burning of trash. So trash is burned and then the particles can float through the air and we can breathe those in. Another way is skin contact, and that's the main way it enters into our bodies at the beach. It comes into contact with our skin and can leach into our pores. Another way is medical exposure. This would be seen as pill caps that are contaminated with microplastics or made entirely out of plastic. So how specifically do they enter into our body through these various ways? Well, through the gestational tract. So on the left, we see how it happens through ingestion. So microplastics are absorbed by gut cells through a process like endocrinosis or phagocytosis. From there, they enter our bloodstream and interact with immune cells. Over time, they can damage our gut health and even reach other organs. And on the right here, you can see the pulmonary exposure. Basically, what happens when we breathe in microplastics? These tiny particles can travel deep into our lungs and can cross into our bloodstream, potentially reaching the brain and other vital organs. And now, dermal contact or skin contact. So, once inside, these tiny particles can cross into our bloodstream, like I said, and travel to organs and begin to cause damage. Inside cells, microplastics trigger something called oxidative stress. Basically, an imbalance that damages DNA, proteins, and the mitochondria. This leads to inflammation, aging, and potentially long-term health conditions. They reduce our body's natural antioxidant defenses, making it harder to even repair this damage. The big takeaway is that these plastics don't just pass through us, they stay and interfere with our most basic functions. And now on to some of the more major effects, so our reproductive system and hormone health. So on the left, you can see the male-specific impacts. Microplastics interfere with hormone production, leading to lower testosterone levels, damaged sperm quality, even destruction of the blood-testes barrier. This barrier normally protects sperm from toxins. Increased oxidative stress and cell death can also contribute to reduced fertility. And on the right, we can see the female-specific effects. So microplastics lead to inflammation, oxidative stress, and disruptions of ovarian function, including thinning the lining and ovarian fibrosis. They also affect granulosa cells, which are crucial for healthy egg development. So why is it important to protect ourselves from microplastics, specifically at the beach? Well, at the beach, our absorption of microplastics can increase. So elevated temperature, like the hot weather at the beach, can increase skin permeability, allowing for easier penetration of smaller particles and chemicals. Sweat and heat expand these pores and make it easier for these microplastics to get in. More importantly, heat enhances the leaching effect of plastic additives like phthalates, BPAs, and flame retardants. These are all endocrine disrupting chemicals, which can easily go into the skin when it's hot. And that's enough of how it affects humans. Let's go into marine life. So, bioaccumulation and biomagnification. Microplastics are accumulated in marine organisms and move up the food chain. Predators ingest higher concentrations because the small fish eat small amounts, but then the big fish eat big amounts of the small fish, which increases the total amount within the big fish of microplastics. Also, disruption of digestive systems. So marine animals, like you can see here, he might mistake the bag for food, and it can clog his organs and clog his digestive tract and can cause death and major blockage. This can lead to malnutrition and reduced growth rates. Another way is chemical contamination. Microplastics absorb harmful pollutants like heavy metals and pesticides, and these enter, affecting the reproductive and immunity defenses of fishes. Other prior research. Another fact that other studies have found is that microplastics have been found in every ecosystem on the planet. Something else is studies have shown that beaches serve as both a sink and the source of microplastics, but are much less studied than open water. They have found correlation between human activity and microplastic pollution, but these lack localized comparisons. Many studies have mapped high concentration gyres, which are large trash islands in the middle of the ocean. However, these focus on open water and not beach sand. A 2019 Florida study potentially linked tourist-heavy beaches to higher microplastic levels. So the research gap. So the gap I'm going to be filling with this research is most existing research does not compare microplastic levels within a localized area based on human presence. My project aims to fill that gap by studying 6 different beaches within St. Lucie County with varying levels of human activity, testing whether there's a correlation between foot traffic and microplastic levels within a localized area. So my hypothesis. So my null hypothesis for the experiment is going to state that the beaches will have the same number of microplastics no matter the foot traffic due to tides evenly distributing these particles. However, I hypothesize that public beaches will have high levels of microplastic due to them having significantly more foot traffic. So the residential and state protected beaches will have much less concentration. So now on to my experiment. I selected 6 beaches categorized as public, residential, and protected. These sites I chose because they're all located evenly throughout St. Lucie County, as you can see here. At each site, I collected 50 grams of sand. I collected 50 grams of 3 times at each beach, all taken at different distances from the shore. So I had 3 samples of sand from each beach. After taking these samples, I brought them to the lab and I made a solution of 35 grams per salt water. So this solution is going to simulate ocean water. There's going to be 35 grams of salt per liter of water within the solution. So this is going to simulate the microplastics that float on the top of the water within our ocean. So I added the 50 grams of sand solution to a 200 milliliter beaker. Then I added 200 milliliters of the salt solution. I mixed it around and let it sit for 10 minutes to allow the microplastics to float to the top of the beaker. After that, I collected the top layer of water into a petri dish, and I examined this under a dissection microscope. I tallied up every microplastic found and matched it to a microplastic identification sheet to make sure it was an inorganic compound. Here are some microplastics I found during my testing. This confirms that there are microplastics at the beach and they've been left there. So, results. As you can see here, while I was testing, I tallied up each microplastic I found and I put it into a chart. But to make that easier to see, I took the average and I put it in this graph. So looking at the data, we see that public beaches like Jetty Park and Gentian Beach Park had the highest microplastic counts across all 3 trials. They averaged about 8.3 microplastics per 50 grams. And we can also see that the residential and state protected beaches had much lower levels of microplastics, and they averaged just about 2.3 to 3 microplastics per 50 grams. So this shows that population levels can affect the microplastic concentrations within sand. But why is this? Why do population levels affect the amount of microplastics? Well, the reason behind this is most likely because residential beaches and state protected beaches have the lowest foot traffic out of all the beaches. Residential beaches specifically have even lower foot traffic because they're only open to residents, and the residents most likely feel more responsible for the trash they bring, and they will leave the beaches cleaner than they found it and pick up the trash as they go along. So what does this tell us? Well, this data supports the conclusion that human activity is a key factor in the accumulation of microplastics on beaches. Public beaches, often overcrowded and less regulated, exhibit the highest level of contamination. Meanwhile, state protected beaches with limited access and stronger conservation policies show much lower levels. But why does this matter? And what can we do? Well, these findings have serious implications for environmental and public health policies. First, they show the effectiveness of conservations. Protected beaches had less plastic. So this means that stricter policies and reduced foot traffics truly do help. But what can we do as a community to improve microplastic pollution and reduce it? Well, we can organize or participate in beach cleanups, we can reduce single-use plastics at the beach, and we can use reusable water bottles and bags and containers, and educate others about microplastics. What can the government and what are some policy solutions? Well, they can enforce stricter littering and dumping laws, increase the number of recycling and waste bins on public beaches, ban single-use plastics in coastal areas, expand the protected and state-managed beach zones, and invest in biodegradable packaging and plastic alternatives. But what is the biggest thing we can do as a society as a whole? Well, we can shift away from single-use plastics in grocery stores and move more towards glass and metal packaging, which was used before the invention of plastics, which is much better for the environment and for us. So what were some limitations I faced in this study? Well, I lacked a high-resolution microscope. So microplastics, as I said earlier, can get as small as 1 nanometer, which is very hard to see with a dissection microscope. My microscope, I can only see plastics as small as 0.2 millimeters. And that's about 200 nanometers. So I really couldn't see the smallest microplastics, which are the most prevalent and also the most dangerous. Another limitation was the potential misidentification of microplastics. So organic materials like shell fragments and algae or cellulose could have been mistaken for microplastics, and vice versa, especially if they're irregular shaped or translucent. Another limitation is the geographic scope. I only focused on studies on beaches in St. Lucie County, which the population levels do not represent all the beaches in the world or even Florida, considering the population levels are much lower here than other highly populated beaches like Miami. Another limitation was temporal. So I took my test during the winter, so the seasons could have changed my results. So maybe if I did in summer, there'd be more people and more microplastics. Another limitation was my trial count. I only did 3 samples per beach and only used 6 beaches. However, this did establish a baseline. More samples would improve my confidence within my study. Thank you. And here are my sources.
Jade, how did the initial exploration of the scholarly conversation around this topic lead you to your final research question?
So initially, like I stated in my literature review, a lot of studies only focused on maybe third world country beaches where the trash is dumped directly, which are obviously going to have a much higher level. But I wanted to concentrate on how they affect the United States beaches because we often don't see the big trash gyres right on our coast because that's over there. So this trash can be moved around, and I want to see how it affected us locally, and that led me to my question of how microplastics affect our beaches.
How do your findings provide directions for future research in the field?
So my findings proved that there are, in fact, microplastics in our beaches. When I started, I was unsure if I would even see any microplastics under my microscope. But this showed that there are indeed plastics there, and there's quite a few of them. So that's going to help people see that we need to study our beaches, and we need to help this tragedy.
How did you handle the uncertainty of the research process?
So like I said in the last question, I wasn't sure if I was even going to find any microplastics. But how I handled that is, after going through the literature review, I saw that there's so many microplastics in all these other beaches around the world. There has to be some within our own beaches, and that's how I face the uncertainty.
Guys,